The objective of this exercise is to build a simple Icepak model. Assign a few boundary conditions, get more familiarity with Icepak GUI and controls, and then explore some tips to increase the productivity. That is how to copy objects, snap geometries, organize components, rename and edit multiple objects. So we will build the model from scratch, and we will have different aspects of the model which will be brought in. That is fans, grids, boards, heatsinks, DDR memory, and flash memories. So once you have started Icepak, you create a new project. Now we will set the default units. We'll go to File, Edit, Preference, Units, Length. We will also change the volume fluid. CFM, set as default this project. Go to Preference, change the display setting, set the screen direction in the Z direction. Add a cabinet. The shape is prism. We will apply a dimension. Go to Properties, change properties. I want to add a heat transfer coefficient to the walls. Click Edit. Heat transfer coefficient 10 watt per Kelvin meter square. Constant. And it goes to the ambient air. Done. Now we will add fan. This is the fan geometry. 2D geometry. Let's add the plane location. Properties, intake type fan. Fixed flow type and CFM. This has happened because we made a mistake in the plane. The plane should have been YC. Now when we update, you can see the fan is correct. We are done. What we will do to add the next fan is we'll just right click and copy. Create number of copies as 1. We'll translate the copy. Offset the fan minus 60 mm in the y direction. Apply. We have two fans now. Next, we will add a block. Click on the block. Go to geometry, properties, specify dimension. Properties, the solid material. Choose between a lot of objects. In this case, we will use FR4. Look at the properties of the material and see the conductivity. In this case, it says isotropic. Might not be true in a real world. Now, if you want, you can change the material property or define your own material. To do that, you click on create material, go to properties, and you can define the properties here. Now we have an article material property. When you look at it, property has changed. Now we will add heat sources. Provide the location. Name them. Choose one. Change the specification. Properties. Notes. Heat source. We'll change the preference. Heading. Start length. This project. We'll add another heat source. Geometry. Now default start length. Please 0.5 watt constant. Done. Next heat source. geometry. (1.5 watt constant). We'll just copy those three and translate it by 18 mm. Again, we are going to copy those 3 and 3.1, translate them 33 mm. Add another block. At this time, we will try to create a network block. Let's name it. Provide geometry dimension. Select network. Register. You select the minimum Z. It's the board side. Let's provide the registers values. Mass and specific heat values are not required for steady state problems as an input. And just click done. We'll create another network block. On network block 2, we can add nodes such as which provides more information about what you are trying to model. Now we will add a heatsink. This is the heatsink. We call it. I want to change the plane to X, Y. We'll be using the start end option. Leave the base right. Provide the overall height. Into properties. In the X direction, longitudinal. This says that the dimensions are bigger than the box, as you can see. For the time being, we will use allow out. And then reposition the heat sinks properly. Select heatsink 1. We'll use the orange buttons here to snap the heatsink onto the network block 2. Now it's aligned. And you can see now the heatsink is within the cabinet because it has been snapped to network block 2 top. We will try to position this heatsink on top of the network block correctly. And now you can see it has properly fit the network block. And we will rename all the options. So this will be fan left, right,
This is a reminder. Click to get OJAs. This is a reminder. Click to get OJAs.
You can also create groups together. Now select the DDRs, right click, create group. You can see the groups bring all the DDR RAMs together. You can also create new groups like RAM. You can add names to it. Use asterisks and X and should be able to find the fans and add them to the group. Once you have created the groups, you can actually do multi-edit. You can just right click, edit object. You can change the properties. Let's change it to 1.25 for all the DDRMs and click on done. You can also activate and deactivate components. So you can activate all, deactivate all if necessary. Similarly, we can edit object of the fan. We'll change the flow rate to 5 CFM for both the fans. Set it to fixed. Done. Now we will change the model object. So we will select memories, the flash. They should be of the same type. Click edit. And what we will do, we will add material. Select ceramic material. Done. So in this case, you have a system where you have the heatsink added, but first you want to evaluate how much will be the temperature of the system, what will be the maximum temperature of the die if there was no heatsink. So you don't need to delete the heatsink. What you can do is you can just go to the heatsink block or right click and you can basically deactivate it. So it's just inactivated. So the heatsink block is still there, but it will not be solved. So you will be solving the case for when there is no heatsink, and then you can directly compare the final results by adding the heatsink and seeing what the final temperatures will be once the heatsink has been added back. So for this case, let's reactivate the heatsink. Inactive component will be here. Click it to active. Once it's active, it will come back to under the heatsink. In order to make sure all the objects are properly placed, we can use the distance. We can compute the distance between objects and debug the object placement. So what we will do is we will go to view, distance, and you can left click between two objects to view the distance. Right? 1, 2. So it will immediately show you what's the distance between two objects. 1, 2. Distance between two objects can be easily computed using this. It's a very handy tool. And the same value will also come up in the console. Right click to exit the distance tool. Now we will save the model. Go to File, Project, and you can then save the model as WS1. The default extension is .tzr. Finally, we just verify the power values that we have provided. We go to model and check the power and temperature limits, and it will all tell us what is the power value that we have provided for different units in a single window. Also, default temperature limit will also be provided. Our temperatures are in degrees C and the values of power are in watts. Thank you.